Good morning, children. Let us continue learning about the types of motion, and also today in today's class we are going to learn about the distance time graphs. By learning about the different types of motions, we understood that an object, when it is changing its position with respect to time and also with the respect to the stationary object in the surrounding, it is said to be in motion. So when it is changing its position, and also later we also understood that how to calculate the speed of the object. So now when we talk about speed of an object, speed is equal to distance traveled by time taken. Now, so today's class we are going to learn about distance time graphs. You all are familiar with graphs. So graphs are used to represent a given data. Yes, no children. So in the newspapers and magazines you might have seen several types of graphs showing to make us understand the given data. So graphical representation of a data given, it is what represented in the graphs. We can represent the data in pictorial form by three ways. You all know about the bar graphs. In your lower classes you might have learnt about the bar graphs. So here also there is one bar graph shown. Students' favorite color, a number of students and versus the favorite color, and just by looking at the graph only easily we can identify red color is the favorite for many children. So graphs also make us not only attractive, they also help us to understand the concept in an easy way. What for the data, for example, when you go to your doctor, your height and weight, generally by seeing the graph only we can understand that whether your weight is in a healthy way as per your height. So like that in our everyday life many times we use this any one of these type of graphs. You can see bar graph, pie chart and also line graph. So now let us see pie chart. One example, see here the pie chart. So this pie chart, here is the pie chart is showing the composition of gases. So nitrogen how many percentage, oxygen how many percentage, and also the other gases. So simple way, as soon as you see when the different colors are given, easily we can understand from this pie chart the composition of the gases. The third one is the line graph. So you can see there is an example of line graph given. That is what is going to be our distance time graph. Distance time graphs are line graphs. So let us start how to. So here you can see another bar graph which is showing the runs scored by a team in each hour. So in a simple way you can see 1 hour overs in one axis and runs in one axis. It has been taken in the graph, and seeing the graph easily we can identify then in which over the maximum runs were scored. So this is one bar graph, and also this is a same way the pie chart representing the composition of air. So when it is given different colors, easily we can variate the composition, what are the gases present in an easy way. So generally graphs help us to understand the concepts in an easy way and an attractive way. So next is our line graph. That is what we are going to learn today. Distance time graphs are line graphs. Generally children, you all know how a graph sheet will be. So when we take a graph sheet, so here you can see a typical graph sheet. So in a graph sheet, when we draw the lines, you know that this graph how to make use it of to draw bar graphs and all. So now we are going to use it for drawing the distance time graph. So generally we have to draw two lines perpendicular to each other. Two lines, no children, equally will divide it by drawing two perpendicular lines. And also you will mark here, as I said, as it is shown, x1 ox, and also there y1 o yr. You can x dash o x, y dash o y o y dash. So now you can see this left side, the x dash y dash part, it will be used for representing the negative values. You might have integers and all. When you learned in the mathematics, you might have learned the negative values will be represented in the graph in this x O2 x dash and O2 y dash part. So now today's class we are going to learn about the positive values. So that it comes in between the OX and OY. We will concentrate on that part only, OX OY part of the graph. So it will be easy for us to plot the graph and understand the details, what all we have to get it. So now here is a very simple data given. So data we are learning, we said repeatedly, here we should have a data to apply to mark on the graph, and then from that we have to understand certain details. So here there is a simple data given. So as we are dealing about the motion, the chapters about motion, here data is given. It is from your textbook only for your easy understanding. Motion of a car, you can see the tabular column, serial number, time, distance. There is no much complication in understanding that. Time is given in minutes and distance in kilometers. You can see specifications also. The first data is time. When the time is 0 minutes, distance is also 0 minutes. So it is not started to move the car. Next, after 1 minute, it has covered 1 kilometer. After 2 minutes, it has covered 2 kilometers. After 3 minutes, the car has covered 3 kilometers. After 4 minutes, you can see the car has covered 4 kilometers. So we using this, how are we going to plot the graph? So as I told you, now in the graph, you will be taking the horizontal and the vertical line. Horizontal line OX and OY. So positive values, all these are positive values. So we are going to plot in the graph. You all know that before plotting the graph, we need to take the, see, this is how your graph will be. No, graph paper will be. So here you need the scale. You will write the scale in the right side corner, no children. One here, that 1 centimeter, that each square 1 centimeter is equal to 1 centimeter in the x-axis is equal to 1 centimeter in the y-axis is equal to, you have to write. Now clearly you observe the same data only here also in a colorful way. It is there. 1 minute, 1 kilometer. After 1 minute it is 2 kilometers. 2 minutes, 3 minutes. So that is actually 2 minutes, children. So that slowly you can 1, 2, 3, 4 like that it is, and the distance is also been changing. So that is what it is. We have to plot it. Now in the x-axis. So x-axis we are going to take the time. Always x-axis we will be taking the time. Why? Because time is an independent quantity. So always time. If time and any other quantity versus when it comes, the time will be in the x-axis. Here distance versus time we are going to plot the graph. Distance time graph. No. So time is always taken in the x-axis, and the O is the point where the two axis meets. That is the origin point, O. So from there you will you will start marking the you will take the scale, no children. 1 centimeter. See in the x-axis you can see, observe the time in minutes. 1 minute, 2 minute, 3 minute, 4 minute, 5 minute, 6 minute. And you see in the y-axis from the O, from 0, 1, 2, 3, 4, that is in the kilometers. 1 kilometer, 2 kilometer, 3 kilometer, 4 kilometer, like that it goes. Now how will you plot now? As per the given data, after 1 minute it has covered 1 kilometer. So you have to keep the dot there. Then by mistake it is given as 1 minute only in the tabular column, children, but it is 2 minutes, again 2 kilometers, 3 minutes, 3 kilometers, 4 minutes, 4 kilometers, 5 minutes, 5 kilometers, 6 minutes, 6 kilometers. You keep on plotting that. Then you will after that you have to join that straight line, join the dots, and you will be getting a straight line. And so from this graph, so as soon as, like the pie chart or the bar graph, as soon as you see, you are able to identify which was the favorite color, which over they got the highest score. Same way here, the straight line indicates that. The straight line is indicating that the car is moving with constant speed. How? See now, speed. How are you able to calculate the speed here? So what is speed, children? Distance traveled by time taken. So now for every minute and every a distance what it is covered. Can we able to find out the speed? Yes. See now, the first data is 0 and 0, it is not, is at rest. Yes. Next, see 1 minute and 1 kilometer. So what is the speed there? Distance traveled is 1 kilometer and time taken is 1 minute. So 1 kilometer, 1 by 1. So what is the speed there? 1 kilometer per minute. Yes. The second one you take 2 minutes for 2 kilometers. So distance traveled is 2 kilometers for 2 minutes. Again 2 by 2. What is the speed there? 1 kilometer per minute. Again 3 kilometers 3 minutes. So what is the speed there? 3 kilometers per minute. So same way up to the 6. So what we have plotted here, 6 minutes, 6 kilometers in 6 minutes. That is 6 by 6. Your speed is equal to, you will write, so that will 1 kilometer per minute. So the car is moving with constant, means the equal distances and equal intervals of time it is covering. That is how the straight line we have achieved, we are able to get while joining the dots. So as soon as seeing the straight line, we can able to identify that the car or any object mentioned in the graph is moving with a constant speed. Next, we'll move on. So now, same way only, how one by one, step by step, how to plot that, it is shown in your textbook. You can open your textbook. In page number 153, you have the clear explanation how to plot and how to draw the lines, so that you will be able to understand that after 1 minute, that is 1 kilometer, 2 minutes, 2 kilometers, everything. So not only the speed, children, speed is equal to, you can distance traveled by time taken. Also this graph you can find out that particular instant what is the distance travel, and particular distance what it has traveled, what is the time taken. That means, see, for example, in this given picture now, the question there can be a question like this: how much distance the car has covered after 1 minute. So how to find out that? Just you have to, after plot, keeping the dot, you draw the lines perpendicular. So from 1, when you extend the line, you can see that it has covered 1 kilometer. What is the distance covered by the car after 2 minutes? Just to draw the perpendiculars and you can come to a conclusion 2 kilometers. Same way, after when the car has covered 3 kilometers, to cover 3 kilometers, what is the time taken by the car? That also by plotting the drawing the perpendiculars, you can find out that it has taken 3 minutes or it has taken 4 minutes. So by using these graphs, not only you can find out whether it is the motion of the car or any object is uniform or non-uniform, and also whether you can find out the speed of the car, and also in particular time taken to cover a particular distance, and a particular distance what was the time taken. That is called as instantaneous time and instantaneous distance covered also. So now same way only, see here, step by step it has been given, you can, for your easy understanding. Now you see here another graph. So that was the data was 0, 1, 2, 3, 4, 5, no children. So here the time is in seconds and the position is nothing but distance. In meters it is given. You can see, you can make a tabular column for this and you can draw and you can see, plot and see in your notebook, and you can understand that why it is not only seeing that the straight line, it is moving in the uniform motion. Also you can understand every interval of time, the equal interval of time, the distance traveled and the speed is in instant. So even that, as I explained, you can in the earlier case you can find out here also. You see here children, so after 1 second, so after 0 seconds, it was in the position also in 0 meters only. So after 1 second the object has moved 10 meters. After 2 seconds the object has moved 20 meters. After 3 seconds the object has changed position to 30 meters. After 4 seconds 40 meters. After 5 seconds it is 50 meters. So now what is the speed? What is the speed of the object? How can we say it is undergoing a constant? Not only seeing the slope, how see you can calculate the 10 is the first 10 meters by 1, then 20 meters by 2, 30 meters by 3, 40 meters by 4, 50 meters by 5. For every interval of time, when you calculate the speed is 50 by 5, 10. So 10 meters per second, that is equal intervals of time, it is covering equal distances. So from the graph you can understand that object is undergoing uniform motion. Now, so here distance time, again an example showing the uniform constant speed. Now if suppose, so far we discussed about the constant speed. If suppose it is having like in the previous class as we discussed, the speed of the vehicle won't be the same when in the heavy traffic, or when we are in heavy traffic, it will be having variable speed. So such a time when we are plotting the graph, you will be getting a curve like this. This curve, as well as seeing the curve, you can understand that what type of motion the object is undergoing. It is non-uniform motion. So how to know that? So even you can see here what is taken in the x-axis, 1, 2, 3, maybe it is seconds or minutes you can write, and if there see 50, 100, 150, 200 in the meters you can write. And when you are calculating after 2 minutes, you can see what is the speed. After 3 minutes, what is the speed. After 4 minutes, what is the speed. You will be seeing that the object is having variable speed. So from the graph also you can understand, and also you can prove it how it is showing the variable speed. This you can you can 2, 3, 4 you can take up, and after 2 minutes, 3 minutes, 4 minutes you can calculate the speed, and you can understand that the speed is varying. That is what the object is under non-uniform motion. The graph will be as a curve. So here also another example for non-uniform motion. It may come like this, but here also it is increasing speed only. The graph is moving upward, so it is the speed is increasing, but it is not uniform. Yes, no children. Now see here, uniform speed, non-uniform speed, and stationary objects. So try to understand that. So distance time, as again I repeat, distance time graphs, how will you plot? In the x-axis, time should be taken. In the y-axis, distance should be taken, and you will be scale you can take as per the data given to you. 1 centimeter is equal to 10 minutes or 1 second, or as per the data for what we are going to plot the graph. Accordingly you will be taking the scale, and you have to start plotting. But just by seeing the graph only we can understand that what type of motion that does the object is undergoing. See the first one, you see seeing this straight line, the slope, seeing the straight line only we can say that the object is moving in uniform motion. And seeing the curve as per the second case, we can say that it is in the it is undergoing non-uniform motion. The third one, you see children, time is passing, but as a parked car or whenever anything is under rest, there is no, see time is passing, but there is no change in the distance. So such type you will get a parallel line to the x-axis. Whenever you see a parallel line to the x-axis in the distance time graph, you can understand that the object is it is a stationary object, or the object is at rest. So now here, so distance time graph only, here you can see they have taken 3 objects and they have plotted the graph. All are in increasing speed only, but how to conclude that which is moving faster or slower? So the same data what we have taken, and 2-3 data, if it when you are plotting, for 2-3 objects, how will you know that which is moving faster or slower? Here also you can think. For example, see here, the slow, it is mentioned as one is moving as slow and fast. So the fastest will be always, it will be closer to the y-axis. Why? See, you select a particular time. In the x-axis, you select one particular time. For example, 4 minutes or 5 minutes or any one particular time. You can draw the perpendiculars and you can find out the distance travel. So when you see that, you will be able to find out that in that particular time what you have taken, the object which is drawn, which is near to the near to the y-axis, it might have covered the might have covered more distance compared to the one which is closer to the x-axis. Just by seeing the graph only, you can identify which is moving faster or slower. That you can prove by drawing the perpendiculars also. That's what I am trying to say you. So from this graph, even you can mention 0, 1, 2, 3, 4 minutes. You can just try copy this and you can write. Then there you can mention as 10 minutes, 10 meters, 20 meters, like that. So in a particular time, at that is after 5 minutes or 6 minutes, you draw perpendiculars and you see that which one is moving, which one has covered more distance. You will be finding that the one which the object which is the slope, which is the line which is near to the y axis might have covered the more distance, that is, it is moving faster than the object that is mentioned in the, you can see that other two the fastest one might have covered more distance. The speed will be more than the object. So you can plot it as ABC. Even in your textbook, one example is there that you can try and understand. Now see here, you see many graphs are being given, and same you can copy in your notebook and you can try to name or identify what type of motion in each case the body is undergoing. The first one you see it is at rest. Second one you see it is not starting from the origin, but it is with a constant speed. The C1 you see, children, C1 it is the slope is in a different way. So this shows the decreasing speed is decreasing from the highway to city. Inside, if you move, how the speed will be decreasing. That shows the decreasing speed. And D, E, F also you can observe when you try to write what type of motion, uniform or non-uniform, or it is at rest, or speed is increasing or decreasing. You can, how far you understood, you can mention, children. Now, and there is two questions at 12 and 13 in your textbook, page number 157. So try to answer them also. So far what have we discussed? Distance time graphs. Why are they important? From the distance time graphs we can find the speed of the object. That is one thing. And also we can identify whether the object or body is moving in uniform motion or non-uniform motion. And also we can know whether the speed is increasing or decreasing, and also we can know at a particular instantaneous speed also can be particular time, 2 minutes or 3 minutes, what was the speed. So that also can be calculated. That is why they are very important part of our this motion and time learning. So in your textbook there is another one about the odometer reading. There is one graph is given in a tabular column is given in 151. You can try to plot a graph for that, and also you can apart from this you can do that and you can try to understand. Once if you read the textbook, you will be able to follow how to plot the distance time graphs, children. Let us meet in the next class. Bye bye, children.